We are studying here graphical analysis of motion. An alternative method of solving dynamics problems is to represent the motion of the body graphically. In general, graphs which illustrate the motion of various particles will emphasize the vector nature of displacement, velocity, and acceleration. We basically treat with three types of graphs: displacement time graph, velocity time graph, and acceleration time graph. However, we will also be discussing other interrelated graphs. In this lecture, let us classify the graphical analysis for the motion of a particle. Let us classify the main graphs which we are going to discuss. Let us x-axis be the path of motion, then x-coordinate of position will represent the magnitude of position vector. Here we are considering motion of a particle to be along x-axis with positive side of x-axis means the direction of motion. Here we will be discussing mainly with the three graphs. One is the position time graph, other one is velocity time graph, and acceleration time graph. We will be taking x-axis of the coordinate system to be the time, and on the y-axis we will take position of the particle in position time graph. In VT graph we will be taking y direction to be the on the velocity time graph. Along the y-axis we will take the velocity of the particle, and on acceleration time graph we will take acceleration along the y-axis. First of all, we are going to discuss position time graph. If we plot time t along the x-axis and the corresponding position x, which is we are taking on y-axis, then from origin to that particular value of x, we will get the initial position of the particle. This graph, which is drawn between position and time, is very convenient to analyze different aspects of motion of a particle. Let us consider some of the cases. I am talking here for these three graphs. In general, 8 ones. For different cases, first I will draw these graphs. Displacement time graph means position time graph, velocity time graph, and acceleration time graph. We will take a overview of these graphs first, then we will discuss separately all these three graphs. So let us first of all draw these three different graphs for a stationary particle which is at rest at some position x. Then what will happen? Just see these three graphs for, say, for stationary particle. If we draw position time curve, then we can say that the displacement or position time graph could be represented by the solid line or a dotted line depending upon on which direction is taken as the positive direction. And more concisely, if we say position of the particle is x and it is at rest at its position, then we can draw a straight line parallel to the time axis, because at all times its position is same because it is not moving. If we talk about velocity time graph, as particle is at rest, so its velocity is 0 at all times. So we can draw a line on the time axis itself as we are taking velocity 0 at this point. And what about the acceleration? Again, as there is no velocity, particle is at rest, so there will be no acceleration at all. So acceleration time graph will also be the same as velocity time graph in this case. If we talk about a particle moving with uniform velocity in a stated direction, then for a particle with uniform velocity, we can draw. So for a particle with uniform velocity, we can draw these graphs as for position time curve, we will plot a straight line making some angle with the time axis. Here, particle's position is increasing with time, or if particle is moving in negative direction, then we can say this curve will become a line with negative slope. Here, as velocity of the particle is constant, say it is something v naught, then we can draw a straight line parallel to the time axis because its velocity at all times remains same, say v naught. If we talk about the acceleration time graph for the same particle which is moving with constant velocity, then this graph will be a straight line along the time axis with zero acceleration because particle's velocity is constant. So acceleration will be zero at all times. Now, if we draw the same curves for a particle moving with uniform acceleration. So for a particle with uniform acceleration, these three graphs will acquire a shape. So for a particle moving with uniform acceleration, these curves will acquire the shape like this. Position is changing non-uniformly with time. If we talk about velocity time curve, then no doubt this curve will be a straight line making some angle with the time axis because slope of velocity time curve gives us the acceleration and acceleration is constant here. If we draw acceleration versus time graph, then this acceleration for the given particle will be uniform, means a straight line parallel to the time axis. So what we have seen that for different particles, either it is at rest or moving with uniform velocity or with uniform acceleration, we can draw these curves just for the reference that how they move. Here, as you have seen, by studying these graphs, we can find all the details related to their motion or their position. Here, how to study these graphs for the particle in detail. So, to get this fact, we are doing the same thing. We are basically clarifying that what things that position time graph gives us, what we can do with velocity time graph and acceleration time graph, what they gives. So in detail, let us discuss different quantities which we are using here to draw graphs. If we compare these three quantities on graphical scale, then we can find it easy to relate velocity acceleration with the position. By the definitions of position, velocity and acceleration, we can easily find that slope of position time curve, it gives us velocity, and slope of velocity time curve gives us acceleration. If we talk about the area under the acceleration time curve, it gives us change in velocity, and area under the velocity time curve, it gives change in position, or you can say displacement. As we can find velocity v as a derivative of position. So derivative, as we know, derivative is the slope. So position time graph on differentiating or finding slope, we get velocity of the particle, and as we know that acceleration is derivative of velocity, so slope of velocity time curve gives us acceleration. Similarly, as we know that change in velocity is integration a dt, which means area bounded by acceleration time curve, and change in position, you can say displacement, it can be obtained by integration v dt, means area under velocity time curve. It gives us displacement. Now this is the mathematical, or as you can see here, velocity can be obtained by slope of position time curve. So how will we obtain it? Just see here, I am discussing velocity from position time curve. Just consider we are having position time curve for a particle. Say this curve is drawn in this form. Say the position time graph for a particle is described by this line. If we talk about motion of the particle from time t1 till time t2, we can easily conclude from here that the position x1 of the particle at time t1, it can be marked here, and for the time t2 we can easily conclude position of the particle, say it is x2. Now we know the initial and final position of the particle. If we draw a straight line connecting these two corresponding points on this position time curve, say point A corresponds to the position of particle at time t1 and point B corresponds to the position of the particle at time t2. As we know, we can find here two basic terms. One term is average velocity. Average velocity, which is defined as change in position divided by time taken. From this curve, we can easily get change in position as the markings between final position and initial position, say x2 minus x1 is delta x, and for these two corresponding positions times are t2 and t1. So we can get time taken delta t as the time t2 minus time t1. Now if we see this section, it is equivalent to delta x. So this is delta x, which can be written as x2 minus x1, final position minus initial position, and this time interval delta t, which can be taken from here as t2 minus t1 in this curve. So we can write delta x as x2 minus x1 here, and time to be t2 minus t1. Here you can easily see that this line passing through the points A and B is code to this curve, and the term delta x upon delta t, it gives slope to this line. So x2 minus x1 upon t2 minus t1 can be taken as slope of chord on this xt curve. So graphically we can achieve average velocity from the position time curve by taking the slope of the chord for the corresponding points for that particle.